So this lesson on 2.5 is about similar figures. In the past, we talked about congruent figures when we translated, rotated, and reflected figures, and now we're going to start talking about similar figures and their properties. If you remember from before, when we say that triangles or any figure is congruent, we use the congruent symbol, and ABC and DEF are congruent. Notice by the shapes that they are both the same size, and now we have to determine what the corresponding sides are. What that means is that in the figure, when you're mentioning A, B, C, and D, E, F, the order that the points are mentioned is also the same for the second figure. So for the angles, angle A and angle D are not only corresponding, but they're equal. Same thing for sides. If you take side AB, it's equal to side DE, because if you notice in the order that they're mentioned, A and B are first, D and E are first in the statement. So if you notice the symbol inside in between them, it's an equal sign. So on your notebook or on your note sheet, you can take and try to fill in the rest of the angles and sides for the congruent figures A, B, C, and D, E, F. So here's the completed corresponding sides for the congruent figures. The next thing I'm going to show you is the similar figures. It's just about the same, only notice that the similar sign right up here is the equal sign is missing. So we know that they're not equal. However, it does share some properties of congruence. In similar figures, the angles are still equal. So A and D, B and E, and C and F are all equal. The angles don't change. The only thing that changes is the sides. Notice the symbols in between. Do you think the numbers or the properties of those sides has changed? Well, AB and DE are similar. Notice the sign in between. BC and EF are similar. And finally, AC and DF. And we're going to focus on a couple of those pairs right now. Notice the number 9 for Notice the number 3 for DF. Now, if you go down to the bottom where our chart is, AC and DF are similar. So we should be able to create some sort of relationship between the 9 and the 3. Notice here it says BC and EF are also similar. So the 6 and the 2 and the 9 and the 3 should be able to create some type of relationship. That relationship is shown by this fraction. 9 over 6 equals 3 over 2. So the two sides on triangle ABC are equal to the two sides in proportion to triangle DEF. So notice if you wanted to cross multiply, 9 times 2 is 18, 6 times 3 is 18, so they are similar. On your worksheet, if you'd answer number 1, that will give you the corresponding sides and the corresponding angles for the triangle that is mentioned. Do that now. The next part of this is to determine whether two things are similar. So we learned in the last slide that similarity is determined by proportional sides. So in this case, you're given two triangles and their sides. Notice this has been rotated so that the triangles has been flipped upside down. Your job is to determine whether or not their sides form a proportion. And if they are, then they're similar. If they don't, then they are not proportional. The same thing goes for the two parallelograms. Hit pause and answer the two similarity questions you see here by creating a proportion for both. Let's see what we found for the first one. The two triangles are not similar, and here's the proportion you should have come up with. 12 sevenths does not equal 7 over 3.5. When you cross multiply, you do not get equal numbers, and therefore they're not similar. The second one, to see if they're similar, you should have said, yes, they are. And the proportion you should have used to find that out was 8 over 8 equals 8.8 over 4.4 equals 2.2 over 1.1. Simply, they multiply both sides by 4 to get these two fractions. On your worksheet, you have two similar questions, numbers 2 and 3. Hit pause and answer those now. And finally, we have to create a new figure using some type of method. In this case, we're going to increase each side by 5. and we're going to determine whether or not it's similar. So here is the original figure. The three sides are listed. We then increased each side by 5, making it 25, 17, and 13. Your job is to determine whether or not they are similar figures. Take a second and do that now. Okay, you should have determined whether they were similar or not by finding the corresponding sides and creating a proportion. You probably found that they were not proportional. So, the question is, what operations will make figures similar? Do you have to add, subtract, multiply, or divide? Is there a combination that you can use? On the next two questions on your worksheet, you'll be determining whether or not sides are similar by creating a proportion. Finish the rest of the worksheet and answer the question, what operations make figures similar? Bring that in tomorrow.